Okay, two more trig transformation sketches. First one, sketch y equals cos of x plus 30. So like the others, you need to work out what transformation you're dealing with. So cos x is going to cos of x plus 30. So the x is being replaced with x plus 30. So that's equivalent to f of x plus 30. So the cos curve is being moved left by 30 degrees. There's no stretching, so I'm going through 1 and -1. What's useful with these actually is if you let x equal 0, and then y is equal to cos 30, which is equal to root 3 over 2. That's about 0.87. So when x is 30, we're here. When x is 0, sorry, we're at y equals cos 30, which is here, which is root 3 over 2. And then normally cos would come down and go through 90, but because it's being moved left by 30, it's going to go through 60 instead. And then every 90 degrees something will happen. So I can mark off 150, 240, 330, and then that's going to put 360 about there. So cos curve moved left by 30, so it's going to be 60 at -1, that would be at 150, 240 back to 0, 330 will be at 1. And then you'll finish where you start, because in 360 degrees you're going to get one complete cycle of cos. So the end point is going to be level with my root 3 over 2. And then it's just a question of drawing the curve, which is slightly more difficult with the curve and you've got loads of points actually. But there we go. So something like that. That's good enough. It's a bit straight, but it's good enough. So things to note, you need your x-axis intercept, y-axis intercept, limits 1 and -1. Where does it start? Where does it finish? So hopefully that's clear. And last one I'm going to do is a bit easier. And that's just sketch y equals cos x plus 1. Between 0 and 360. So again, just think about your transformation. So cos x is going to cos x plus 1. Be a bit careful with this. This means cos x and then add 1. If it was cos of x plus 1, you would have to put a bracket around that x plus 1. Sometimes, to avoid any confusion, you'll see these written round the other way, so you might see that written as 1 plus cos x. And so f of x is changing to f of x plus 1. And so the cos curve is going to be moved up by 1. So I'm going to be going up to 2 here. And then just think about what happens to your normal cos curve. I'd mark off every 90. So at 90, rather than being at 1, I'm going to be, sorry, at 0. Rather than being at 1, I'm going to be at 2. 90 will be at 1. 180, 0. 271, and then 362. And so cos curve down, round, back up to there. So that's the first 360 degrees of y equals cos x plus 1. What I'll do, I'll just write down on the board for some for you to have a go at sketching. And then I've put some answers on our lesson, so you can check your answers. I've just done a photograph of that earlier. So if you could sketch, we'll just go between 0 and 360. So first of all, y equals cos 2 theta. Secondly, y equals sine of theta minus 45. Then y equals a half sine theta. Then y equals tan of a half x. Don't forget your asymptotes and what happens with those under transformation. So I would think about what happens with the asymptotes first for tan. 5, y equals sine x minus 1. And then last but not least, y equals minus cos x. So similarly, you may actually see that one written as minus 1 plus sine x. So it's sine x and then take away 1. Okay, so if you could draw those, mark on x-axis intercepts, y-axis intercepts, think about your shape, and then there's some answers on OneDrive in the lesson folder. Thank you.